Right now, while you're watching this video, your body is producing almost zero growth hormone. Not because you're getting older, not because something's wrong with you, just because of the last time you ate. And over the next 20 minutes, I'm going to walk you through exactly what happens inside your body, hour by hour, while you sleep, and why the one thing you've been doing every single morning for decades is quietly sabotaging the whole process without you even knowing it. But before we get into all of that, quick introduction for those of you who are new here. My name is Flory, and what I do on this channel is simple. I explain how your body actually works. No jargon, no complicated science, just clear, honest explanations that actually make sense. Because I genuinely believe that when you understand what's happening inside your body, you make better decisions. And better decisions change everything. If you're new here, hit that subscribe button. It's completely free. It costs you nothing. But for me, it means everything. It's what allows me to keep making videos like this one. Now, let's get into it. Because what I'm about to show you will change the way you think about food, time, and your body forever. We're going to cover 5 precise biological phases, the real chemistry, the real studies. And at the end, a 3-step protocol I call the noon reset. No medication, no complicated meal plan, nothing more complex than a clock. But first, I need to tell you about the real villain in this story, and it's not what you think. In a few minutes, I'll tell you why the single most repeated nutrition advice in the world is a lie, one invented by a cereal company, and how it's been costing you your health every single morning. The real culprit is chronically elevated insulin. Insulin is a hormone. Its job is simple. When you eat, your blood sugar rises, insulin shows up. It shuttles glucose into your cells, and it tells your fat cells to lock their doors. As long as insulin is present, your fat doesn't move. Picture a factory manager walking the warehouse floor, telling every single worker, lock it all down, nothing leaves storage. The moment he walks out, the doors open and your body can finally start pulling energy from fat. The problem is that manager never really leaves, because most people eat from 7 a.m. all the way through to 10 p.m. Snacks, fruit, a healthy bite between meals. Every time you put something in your mouth, insulin clocks back in. The doors stay locked for 16, 17 hours a day. You're only burning what just came in. You never touch what's stored. That's the trap. The solution is timing, not willpower. I'm going to show you exactly what happens hour by hour in your body when you finally let that manager leave. And phase 3 is going to genuinely surprise you. Let's say you finish dinner at 8 p.m. Here's what happens. From 8 p.m. to 11 p.m., this is the heavy delivery phase. Your body breaks down your meal into glucose, amino acids, and fatty acids. Blood sugar rises. Insulin spikes with it, sometimes up to 20 times its normal fasting level if you had a high-carb dinner. Your liver gets flooded with glucose and starts compressing it into glycogen. Think of it like zipping a file to put in storage. The liver can hold about 100 grams. Your muscles hold another 300 to 500 grams, depending on how fit you are. You fill those tanks up. You feel full, maybe a little drowsy. That's normal. It's serotonin precursors and blood flow shifting toward your gut. But here's what nobody tells you. During this phase, growth hormone is being actively blocked. Insulin is one of its main suppressors. Your growth hormone, the one that repairs your muscles, burns fat, strengthens your bones, it can't do its job while insulin is high. If you eat at 9 p.m., it takes 2 to 3 hours for insulin to come back down. You're cutting directly into your overnight recovery window. Night after night, year after year. Less muscle repair, more fat stored overnight, slower metabolism. Not dramatically, cumulatively. From about 11 p.m. to 3 a.m., this is what I call the night shift. Insulin drops back toward baseline. Your liver takes over. It slowly and steadily releases stored glucose to feed your brain while you sleep. And your brain needs it. It makes up just 2% of your body weight, but burns through 20% of your total energy. While you're dreaming, your hippocampus is consolidating the memories from your day, Your prefrontal cortex is sorting through your emotions, all of it running quietly in the background, fueled by your liver. Your liver is the silent night delivery driver, working while you sleep without you lifting a finger. Around hour 5 or 6 of fasting, so around 1 a.m. to 2 a.m., something important kicks in. Insulin is low enough that an enzyme inside your fat cells wakes up. It's called hormone-sensitive lipase. Its job, break down stored fat and send it into the bloodstream to be burned. That's lipolysis, fat breakdown. It starts happening while you're in your deepest sleep, completely out cold. But that's nothing compared to what happens between 3 a.m. and 7 a.m. This is where your body does something that Nobel Prize scientists have spent careers studying and that most people completely prevent themselves from ever experiencing. From about 3 a.m. to 7 a.m., your liver's glycogen stores are running seriously low. It's been releasing glucose all night. The tank is nearly empty, so the liver switches modes. It starts pulling fatty acids from the bloodstream and converting them into something remarkable, ketone bodies. Specifically, beta-hydroxybutyrate and acetoacetate. These molecules can cross the blood-brain barrier and directly fuel your neurons. Your brain, which was running purely on glucose a few hours ago, is now accepting a second fuel source. This is called the metabolic switch. Sachin Panda, a circadian biologist at the Salk Institute in San Diego, and Mark Mattson, a neuroscientist who published a landmark paper in the New England Journal of Medicine in 2019, one of the most respected medical journals in the world. Both describe this switch as one of the most important and underestimated aspects of human physiology. For almost all of human history, this switch flipped regularly. Our ancestors didn't eat every 3 hours, meals were sporadic. The shift from burning glucose to burning ketones was normal and recurring. Today, many people go years without ever fully triggering it because they never go long enough without eating to deplete their liver glycogen enough to start producing ketones. The result? Your mitochondria, the power plants inside your cells, become less flexible. They lose the ability to switch fuels smoothly. A study from the National Institute on Aging found that people who regularly trigger this metabolic switch have better insulin sensitivity, lower blood pressure, and measurably lower inflammatory markers. You feel it as mid-morning energy crashes, brain fog before lunch, and an inability to lose weight despite eating what seems like a reasonable diet. That's not aging, that's lost metabolic flexibility. Around hour 12 of fasting, so around 8 a.m., something happens that researchers consider genuinely fundamental. Autophagy kicks into high gear. The word comes from Greek. Auto, self, phagy, eating. Your cells start digesting their own damaged components. Misfolded proteins, worn-out mitochondria, cellular debris that would otherwise pile up. Autophagy identifies this material, tags it, and breaks it down into raw components that can be reused. This isn't destruction, it's renovation. Think of it like a maintenance crew that only gets access to the building once everyone's gone home for the night. This process is so fundamental that Yoshinori Ohsumi won the Nobel Prize in Physiology or Medicine in 2016, specifically for mapping how autophagy works. Why does it ramp up at hour 12 and not before? Because autophagy is blocked by mTOR, a cellular signaling pathway kept active by insulin, glucose, and amino acids from protein. As long as you're eating, mTOR stays on, autophagy stays suppressed. When insulin drops, blood sugar falls, and circulating amino acids decline, mTOR finally quiets down, and autophagy shifts into high gear. Research published in the journal Autophagy measured a significant increase in autophagy markers in human blood after 16 hours of fasting. Animal studies show that chronically suppressing autophagy, which is exactly what constant eating produces, is associated with accelerated accumulation of damaged proteins in the brain. Proteins linked to the plaques and tangles associated with neurodegenerative disease. I'm not saying fasting prevents Alzheimer's. The clinical evidence in humans isn't there yet to make that claim cleanly. What the evidence does show is that the mechanism linking impaired autophagy to neurological damage is real, reproducible, and actively studied in some of the most credible labs in the world. Now I need to tell you about the most profitable lie in the history of nutrition, the one that's probably convinced you to sabotage this entire process every single morning since childhood. Breakfast is the most important meal of the day. You've heard it your whole life. It's printed on cereal boxes. Pediatricians say it. School nutrition programs are built around it. Here's where it actually comes from. In the early 1900s, John Harvey Kellogg, yes, the Kellogg of cornflakes, was a passionate advocate for breakfast eating as a health intervention, partly because he genuinely believed it, and partly because he was selling breakfast products. The food industry amplified this message throughout the 20th century. By the 1980s, it had been so completely absorbed into mainstream medicine that it became established clinical knowledge, even though the underlying evidence for the metabolic superiority of breakfast was, at best, weak and context-dependent. In 2019, a large systematic review published in the BMJ, the British Medical Journal, one of the oldest and most respected medical journals in the world, analyzed 13 randomized controlled trials on breakfast consumption. The conclusion: no consistent evidence that eating breakfast promotes weight loss or improves metabolic health in adults. In fact, in some studies, people who skipped breakfast spontaneously and ate fewer total calories across the entire day without compensating at other meals. The studies that seem to support breakfast, often funded by cereal companies, riddled with confounding variables, or measuring the wrong outcomes. The mandatory breakfast narrative, as it applies to adult metabolic health, is an artifact of industry influence on nutritional science. Not a conspiracy, a financial incentive, a very, very lucrative one. From 10 a.m. to noon, the final 2 hours of your 16-hour fast, something extraordinary happens. Growth hormone surges. Research published in the Journal of Clinical Endocrinology and Metabolism shows that a 24-hour fast increases growth hormone production by 1,300% in men compared to post-meal baseline. A 16-hour fast produces a smaller, but still very significant and measurable spike. Why does this matter, especially after 50? First, growth hormone tells your fat tissue to release stored energy. It burns fat. Second, it protects your muscle mass during the fast itself. This is the question everyone asks. Am I going to lose muscle? The answer, based on the research, is nuanced. A short-term fast, meaning 16 to 24 hours, and it does not cause the muscle breakdown that prolonged caloric restriction does. A study published in Obesity Reviews found that time-restricted eating protocols preserve lean mass significantly better than continuous caloric restriction at the same total caloric deficit. The mechanism is growth hormone. There's also norepinephrine, the same neurotransmitter involved in alertness and focus, which rises during fasting. Counterintuitively, the final hours of a 16-hour fast are often accompanied by sharper mental clarity, not cognitive decline. Why? Because ketone bodies are a more efficient fuel per unit of oxygen than glucose. Neuroscientists describe them as a cleaner burning fuel, a simplification, but one with functional accuracy. Studies show improvements in working memory, sustained attention, and verbal processing in adults over 40 in mild ketosis. And then there's BDNF, brain-derived neurotrophic factor, a protein that promotes the survival of existing neurons and the formation of new neural connections. Low BDNF is associated with depression, cognitive decline, and reduced neuroplasticity. Mark Mattson at the National Institute on Aging specifically identified intermittent fasting as one of the most reliable dietary triggers of BDNF in animal models, and the human data, while less complete, is consistent with those findings. Now that you understand what's happening inside your body, here's exactly how to trigger all of it. With 3 precise steps, miss any one of them, and you lose half the benefit. One quick but critical point for anyone over 50. Insulin sensitivity naturally declines with age. Your cells respond slightly less efficiently to insulin, so your pancreas secretes a little more to compensate. Insulin stays a little higher, fat oxidation goes down, you gain weight gradually, which worsens insulin resistance further. A slow spiral. It doesn't feel like disease, it feels like getting older. Those 2 things have become so confused in our culture that most people accept the weight gain, the energy crashes, and the belly growth as inevitable features of aging, rather than symptoms of a metabolic state they actually have some power over. Sachin Panda's lab published research in 2019 in Cell Metabolism. Overweight adults who compressed their eating to a 10-hour window without being told to eat less, spontaneously consumed fewer calories, and showed improvements in fasting insulin, blood pressure, and cholesterol within 12 weeks. A related study from the University of Alabama at Birmingham published in Obesity. Men with prediabetes who ate within a 6-hour window only, even without caloric restriction, improved their insulin sensitivity 3 times more than the control group in just 5 weeks. The mechanism isn't simply eating less, it's the combination of lower average insulin levels across the day, longer fat-burning windows, and better alignment with your biological clock, because your insulin sensitivity is highest in the morning, not the evening. The same meal eaten at 9 a.m. versus 9 p.m. produces a blood sugar response up to 50% different in the same person on the same day. Your body is not the same machine at night that it is in the morning. Here's the protocol, 3 steps. Each one has a precise purpose. Step 1. Shrink, compress your eating window to 8 hours or less, starting no earlier than noon. First meal at noon. Last meal by 8 p.m. Minimum 16-hour fast. Why 16 hours and not 12? Because 10 to 12-hour windows produce some benefits but consistently fall below the threshold for significant autophagy activation and meaningful growth hormone response in most adults. Biology doesn't negotiate. Classic mistake, start counting your fast from when you stop eating in the evening. Then tell yourself, it's been 12 hours, at 9 a.m. and eat. 12 hours is not 16 hours. Step 2. Optimize. During your 8-hour eating window, target 1.2 grams of protein per kilogram of body weight per day. Spread across your meals rather than eaten all at once. For a 175-pound person, that's roughly 95 grams of protein split between lunch and dinner. Why does this matter? Research from Stuart Phillips' lab at McMaster University is consistent. In people over 50, protein intake is the single most important dietary variable for preserving lean muscle mass. That's roughly double what most older adults actually eat, according to data from the National Health and Nutrition Examination Survey. Fasting until noon without hitting that protein target means you have all the hormonal signals for muscle preservation, but none of the raw material to act on them. Step 3. Shift. In the hour before your first meal at noon, do 20 minutes of light movement. A walk, some body weight exercises, anything that gets your heart rate up slightly. Why? Fasted exercise increases the translocation of GLUT4 transporters, the glucose entry channels on the surface of muscle cells. When you eat afterward, your muscles are significantly more receptive to absorbing glucose. A study published in the Journal of Applied Physiology found that brief, fasted exercise improved glucose uptake at the following meal by around 30% compared to the same meal eaten without prior movement. This isn't the optional step. Without it, you're missing the final priming stage that takes the insulin sensitivity gains from fasting and makes them fully actionable. 3 steps: a specific window, a specific protein number, a specific movement trigger. That's the noon reset. I'm not selling a perfect protocol. There are real categories of people for whom this isn't appropriate. Anyone with a history of eating disorders should not practice time-restricted eating without clinical guidance. Pregnant or breastfeeding women should not restrict their eating window. People on certain diabetes medications, particularly sulfonylureas or injectable insulin, face a real risk of hypoglycemia during extended fasts and need medical supervision before changing their meal timing. Anyone already underweight should not practice any form of restriction without medical oversight. These aren't legal disclaimers. They're real clinical categories where fasting until noon could cause harm. And yes, part of the benefit comes from the fact that people with a shorter eating window tend to spontaneously eat slightly less overall. Both mechanisms probably contribute. Separating them cleanly in human research is genuinely difficult. Work with your doctor. But don't expect your doctor to bring this up unprompted. Most medical training includes virtually no coursework on nutrition timing, and a 15-minute appointment isn't designed for lifestyle conversations. By the time you hit noon, after a 16-hour fast, here's the cumulative metabolic state your body has built. Insulin at its lowest point of the day, glucagon active for hours, fatty acids circulating freely, liver producing ketone bodies, growth hormone surging, autophagy running at full speed. Your gut's cleaning wave has completed multiple cycles. BDNF is elevated. Norepinephrine is sharpening your focus. Your mitochondria have been trained to use both fuel sources. This is not a starvation state. This is the state your body evolved to reach regularly, and that the last century of food industry engineering has systematically prevented you from ever getting to. One last thing: hunger. The first week is uncomfortable. Ghrelin, your hunger hormone, is habit-driven. It peaks at the times you've historically eaten. If you've eaten breakfast at 8 a.m. every day for 20 years, your ghrelin will spike at 8 a.m. That peak is real. That discomfort is real. But ghrelin is one of the most adaptive hormones in your body. Research shows that ghrelin patterns shift significantly within 1 to 2 weeks of a new, consistent eating schedule. The hunger that feels unbearable on day 3 is genuinely reduced by day 10 in most people. That's not motivational talk. That's receptor downregulation and hormonal retraining, documented in studies on meal timing and appetite adaptation. The discomfort is temporary. The metabolic shift is not. If you're going to start the noon reset this week, drop noon in the comments below. I want to see who's actually doing this. And if you want the second half of this equation, exactly what to eat and when within those 8 hours to maximize everything we've covered today, make sure you're subscribed. That video goes deep on protein timing and the specific foods that accelerate or block your autophagy window. And if this video gave you something, if it shifted the way you think about your body even a little, please subscribe. It's completely free. It takes 2 seconds, but it's what allows me to keep making videos like this one, keep researching, and keep breaking this stuff down in a way that actually makes sense. I'm Flory. I'll see you in the next one. Stay informed. Stay healthy.